Hello, it is visible now?
Yes, sir, it is visible.
Yes, sir. Yes, sir.
Right. So let us continue that partition method of finding the solution for the system of linear equations. So yesterday we have seen what is partition method to get the solution of a system of linear equations. So once again, I shall recall this method. In partition method, when a system of equations given, first what we do is write the system in the matrix form as Ax is equal to B, where A is the matrix of the coefficient. We can write this matrix of the coefficient like this. So in this method, to get the solution means we need the value of capital X. X is nothing but the matrix have that column matrix having the unknowns x1, x2, etc. To find the value of X, what you can do is you take A to the right hand side. Taking A to the right hand side means taking the when it goes to right hand side becomes inverse of it. The solution for the system will be given capital X is equal to A inverse into B. B means the right hand side constant of the system. Now, to get A inverse of the matrix, there is a method that is called partition method. So that partition method is used to find the inverse of this matrix, not to get the solution, right? To get the inverse of a matrix, you use this partition method. So here, what we do is, so here the theory behind this is by knowing the inverse of a matrix of order n-1, we find the inverse of the matrix of order n+1. One more column or row is added, how to get the inverse. That concept you right, we use here. So first step, what to do is we partition this matrix A into 4 matrices of this type. We call it as B, C, D, and E, where we just partition like this, right? This C is nothing but the last column of this matrix, last column, except this element because that goes to this row. So C is the last column of this matrix. And what is D? That's the last row without the last element. Here also last column without the last element. So that's C and D. B is the rest of this elements of this matrix. All these are together taken as B. C means that last column and D is the last row except this one. It is taken as C. Like that partition. Once you partition like this, then we assume that the inverse of this matrix will be in this form, just like a partition, right? So to get the inverse of this matrix, what you write, answer directly write like this. That is X, Y, Z, T. Now our problem is to find how to get capital X, how to get capital Y, how to get capital Z and small t. This matrix, these two matrices return small letters because it has only one element, and this also only one element. Now in partition method, as I told, to get the inverse of the system, take this coefficient matrix, just partition like this, assume that inverse is in the form. Now our problem is how to get X, Y, Z, and T. We can write these values in terms of these 4 matrices. For that, first you find the inverse of this matrix B. Let us denote this one by B inverse. So in this method, first get the inverse of B, then the value of T in that inverse matrix. How you written in A inverse? That is A inverse written as X, Y, Z, T. The value of T, that's one element, the last column and last row. This is given by this formula that yesterday seen here, and just repeating that. That's E minus D into inverse of B into C, whole inverse of this. That is how to get the value of T. Then how to get the value of Y? For that, this is the formula. Inverse of B into C into T. But there should be a minus sign. Similarly, you get Z using the formula. Minus T, D, B inverse. So what is B, what is B, what is C, you have to know first in that matrix return. And use this formula to get T, Y, Z. And one more unknown is there, that is capital X. Once you get all this, write the inverse of this matrix. How to get the inverse? Inverse of A is X, Y, Z. Then solution of the system is given by the formula X is equal to A inverse into B. Yesterday I have seen one problem also using partition method how to solve it. So today let us see one problem only to get the inverse of the C. Rest thing is very simple. Once inverse is found, the solution of the system is given by capital X is equal to that inverse into B. B means the constant on the right hand side of the system. When you multiply, directly get a column matrix equal to this. From that, you can get the unknowns. So this step I avoid because in one question paper last year's exam, they asked you only to get the inverse of this. Instead of solving the system of equation by partition method, they given one matrix and ask you to find the inverse of that. Solving, we have seen that method. Today, we shall see how to get only the inverse of a matrix. That matrix nothing but the coefficient matrix. So we shall take one more list example here. Okay, this is the example. Using partition method, find the inverse of the matrix. The first row is here 1, 2, 3. Second row is 0, 1, 4. Third row is 5, 6, 0. Now, you have to note that this matrix is the coefficient matrix of the system of equations. In that coefficient matrix taken, and capital X means that unknowns X, Y, Z like that. We take capital B means constant on the right hand side. But here I will discuss only how to get the inverse of that. Solution, you can directly find it. So what to do first? First, partition this matrix into 4 matrices like this. How we partition? Separate the last column by putting a bar like this, horizontal vertical line. Similarly, take a horizontal line for the last row. Now you partition the given matrix A into like this. So that you name this 2 by 2 matrix. We call it as capital B because A means the given matrix. And this column matrix having only 2 elements. This is taken as C. This is B. It is C. And this row matrix having these 2 elements, we are taken as B, C, D. And this is E. That has only 1 element. So we shall partition like this B, C, D, E. So in this method is very simple. Once this matrix is given, you just partition. Now identify what is B, C, D, and E. What is B here? B is this matrix having these 4 elements. That is, first row is 1, 2, second row is 0, 1. And what is C? That column matrix having these 2 elements. That is C. And what is D? D is this row matrix. And E is here that matrix having the element 0. Or simply you can write 0 without the bracket. If you put bracket or not put bracket, this immaterial. Yeah, you get only 1 element. So very simple method. You should note that how to partition this and how to get this. After that, first step you have to do is that get the inverse of this matrix B. Find the inverse of this matrix B. But how to get the inverse? There's a simple rule. To get the inverse of this, first get the adjoint of this matrix. Adjoint means for a 2 by 2 matrix, what you do is, in the principal diagonal elements, you just interchange these 2 elements. That's all you have to do. Suppose that is 1, it is 3. Then this 3 goes here, 1 comes here. Here, because of this 1 same element, if we interchange same element, you get. In the row column here, for the other diagonal, what to do is, same element you have to keep that, but put a minus sign. This will be minus 2, it is minus 0. Minus 0 means 0 itself. That is adjoint of this. You divide this by determinant of this matrix. How to get the determinant? That is 1 into 1 minus 2 into 0. So that is 1 only. If you divide it, that gives the inverse of this matrix. So for a 2 by 2 matrix, easily we can get the inverse of this matrix without any much work. Actually process that, how to get the cofactors, then get the sign of this. Instead of that, just interchange these 2 elements and put minus and for this, that gives the inverse, divided by its inverse. So inverse of B, before that, we shall assume what is A inverse. A inverse, our problem, aim is to get the inverse of the matrix A. To get the inverse of the matrix A, first we get the inverse of B. How you write the inverse? You can directly write this one as X, Y, Z, T. We find all this separately. To get this, for X, Y, Z, T, we return the formula in terms of the inverse of the matrix B. For that purpose, we are finding the inverse of B first. So when this matrix is given, directly you can write A inverse is equal to this matrix. But you have to find what is X, what is Y, what is Z, what is T. And you have written all this in a formula. In that formula, it contains this inverse of B. So I need first inverse of B. So first get inverse. How to get inverse of B? It is denoted by the symbol 1 over determinant of this. 1 over determinant is 1 into 1, 1 minus 2 into 0, 0. So 1 over minus this. And adjoint of this matrix. Adjoint means you know how to get it, right? Just interchange these two elements. If interchange, we get the same element here. And put the minus sign for these two elements. Only principal diagonal means interchange. Right? This is multiplied minus sign. So you have to take care because here, because of 1, 1, it looks the same element here. Actually, this one goes here, this one comes here. Right? Let it be inverse of B. Once inverse is obtained, then we can get all these values. First, you find T. In this order you go. After T, find Y. After Y, find Z. Then you get X. Or first you find T, then you find Z, then you can go for, at the end you have to get X. So let us see how to get the value of T here. For T, what the formula written? That is E minus D into inverse of B into C whole to the power minus 1. E means, you know, last element that of that is 0. D means the row matrix in A, that is element having 5, 6. Inverse of B, just a return, is 1 minus 2, 0, 1. And C means that column matrix. C means, you can remember, column matrix of this partitioned matrix. Now, first get the product of these two matrices. How to get the product of these two matrices? This is 2 by 2 matrix. This is 2 by 1. Here are 2 rows and 2 columns. This is 2 rows and 1 column. So product of these two will be 2 into 2. That means 2 rows and 1 column must be here. How to find a? The first row into this column is 1 into 3, 3 plus minus 2 into 4 is minus 8. So 3 plus minus 8 means minus 5. So in that column, first element is minus 5. And what is the next element? With respect to this row, 0 into 3 is 0, plus 1 into 4 is 1, 4. So I get minus 5 and 4. So this T is 0 minus this matrix you write as itself, and this one is one step is not written, right? We get phi 1. Again, you multiply by this phi 6 row, this row and this column. Here column is here. This element is minus 5. Here it is 4. So then 25 minus this 24, 6 into 4, 24 again. Then we get this minus 1. So this step is not written. We simplify this. So this minus 0, minus or minus plus 1 again. Inverse of 1. Inverse of 1 means 1 by 1. That is 1 itself. So like that, you have to get the first value T. Once T is obtained, so this product process is not mentioned here. You can do yourself because just calculation only. Next, find Y. For capital Y, what the formula? After T, find the value of capital Y, not X here. You have to take T, then Y, then Z, finally get X. Inverse of B into C into T. Now, inverse of B, what is that? The same matrix here, 1, minus 2, 0, 1 here, right? C means the column matrix written, the same thing, 3, 4. And the T is equal to 1 you got. So, if you substitute, what is this? This much, 3, 4. Now, multiply these two matrices, 1 into 3 is 3, plus minus 2 into 4 is minus 8. 3 minus 8 means minus 5. And this is 0. This is 1 into 4, 4. So 4 only get. So minus 5, 4. One more minus sign is there. Because of that, minus of minus plus 5. And here, minus 4 is there. Just matrix multiplication. But instead of doing like this, if you know how to multiply the matrix using calculator, you can directly write. No need of taking risk. Use calculator and multiply. When you feed that values in calculator, immediately give the answer. No need of multiplying. It is not necessary to know the method of finding the product of two matrices manually. We can use calculator and give the answer. That's all, right? So y is equal to 5 minus 4. So, but you should know how to get the product of these two matrices using calculator. Once you know the process, immediately you give the answer. No need of multiplying by yourself, right? So that is why. Next, find Z. How to get Z? Z is equal to the formula is minus of D into inverse of B into T. T is 1 here. That's 1. B inverse, the same matrix here. D is what? That row matrix of the partition method. Row means that 5, 6 element you return. There is 5, 6. This is a row matrix. This is the inverse of B. T is 1. Multiply these two matrices. 5 into 1, 5, plus 6 into 0, 0 only. So 5 you get. And because of this minus sign, this become minus 5. And here, this next row, 5 into 2, minus 10, 6 into 1, 6. So minus 4 you get. But because of this minus, minus or minus plus. So there is a value of Z. So very simple process. Find T, Y, Z, and one more is there. That is capital X. How to get capital X? For that, this is the formula written. Inverse of B minus inverse of B into C into Z. Inverse of B written. That is the same matrix. Here again, inverse of B. This is C. C means the column matrix. 3, 4. And Z is you obtain in the previous step. That is row matrix. That means a row having only one row, a matrix having only one row. That's minus 5. But here you multiply these two matrices first. This is column. It is row. It has 2 elements. This also 2 elements. If a column has 2 elements, a row has 2 elements. When you multiply these two, we get a matrix of 2 by 2 order. 2 rows and 2 columns. That is 3 into minus 5 minus 15 is the first element in the first row. 3 into 4, it is 12. That is the second element in the first row. In the second row, the elements you got get by multiply 4. 4 into minus 5, that is minus 20. Then 4 into 4, 16. So first you multiply that, these two as itself. The product of this column and this row matrix is we get this much. Now multiply these two matrices. Again, as I told, instead of doing manually, you fill up all this in the calculator for matrix multiplication. It gives the answer directly. If you just feed it, it gives. But you should know how to get it from the calculator. Otherwise, you do manually. Now, product of these two matrices, this matrix minus this 1 into minus 15 plus minus 2 into minus 20 plus 40 get 40 minus 15 is 25. Similarly, 1 into 12 plus minus 2 into 16. Here it is 12 minus 32. So that we get minus 20 only. Next, 0 into minus 15, 0. Plus 1 into minus 20, minus 20. So this minus 20. Similarly, this into 12, 0. 1 into 16, 16. This much will get. Now, the difference between these two matrices. 1 minus 25, that's minus 24. Minus 2 minus minus 20. So plus 18 you get. 0 minus minus 20 plus 20. 1 minus 16 minus 15. So finally we get like this. So this is what X. So in this partition method, problem is to get X, Y, Z, and T. But in the reverse order, first you write, first you get T, then Y, then Z, finally X. Once all are obtained, directly write the inverse of A. How you write the inverse of A? That is X, Y, Z, T. X means you have written this matrix right here. Y means the column matrix you written there earlier, right? That is 5 and 4 or 5 and 6, I think. Z means just a return here. Where is it? Z. Yes, this is minus 5, 4. And T means that element you return, I think 2 or 4, whatever it may be. Just substitute that value. So T is equal to return 1. And so write all this. No need of partition this matrix. This is the inverse of the given matrix. So once inverse is obtained, if you want to find the solution, you multiply this by the constant, by the unknown column matrix. That means it must be a column matrix having the unknowns. If the unknowns are X, Y, Z, multiplyable. This, so that we need to find it, you multiply this one by the constant on the right hand side. The constant on the right hand side, you get a column matrix only. When you multiply these two, you get a column. That column equate to the unknowns of the system of equation. That is the solution for the system. Only to find the inverse means you can stop here. This is the inverse of the matrix. That is how to get the inverse of a matrix by partition method. Now to get practice, you write 2 more examples and try yourself. I given this example earlier. Okay. So here, now you try to find the solution of system of these two equations by partition method. To get practice, here that coefficient matrix first, right? Partition this, find X, Y, Z, like that, what I explained. Then substitute matrix, that is inverse of A. You multiply that inverse by this constant column matrix. So that directly gives the solution X, Y, Z. Similarly, here, find the inverse of that. Multiply that matrix by this column matrix 164. We get a column that is a solution for the system. So like that, you can find the solution. So that is what partition method. So in this model, we have completed almost all part of this except the last part. So solving the system, before that you have seen how to get the rank of a matrix, solving the system by Gauss-Seidel method and Jacobi method. Then you have seen that triangulation method. After that you have seen partition method. And the last part of this is that finding the eigenvalues and eigenvector of a matrix. Now let us see what you mean by eigenvalues and eigenvector of a matrix. Okay. Right, eigenvalues and eigenvectors. So that is related to a matrix. Actually, when a matrix given, it represents some rows and columns, means the elements are arranged. But in analysis purpose, we need what is the dominant element of this matrix that you have to find. So in this regard, for every row, we identify one dominant element. These are treated as some eigenvalues. For analysis purpose, it is required. And similarly, eigenvectors plays an important role in most of the application problems. So application part we shall leave it. Let us see how to get the eigenvalue of a matrix, but it can be obtained only for a square matrix. Suppose that there is a square matrix of order n. Let A be a square matrix of order n. Now, you take an identity matrix of the same order. Let it be I. Identity matrix means the diagonal elements are 1, all other elements are 0. So take an identity matrix of the same order. Then you write an equation, that is, you subtract this lambda times I from this matrix. A means that coefficient matrix, I means identity matrix. When you multiply identity matrix by a scalar lambda, what happens? In that product, only the diagonal elements becomes lambda, lambda, lambda. All the elements are 0. Now, what we have to do is, from the given matrix, you subtract this and get the determinant equal to 0. So if we get an equation, this equation, it is called characteristic of the matrix. So when a matrix given, characteristic equation means you subtract the given matrix. That means take a matrix A here of order n. You multiply the identity matrix by lambda, then you subtract this lambda times I from the given matrix and get the determinant of that. Equal to 0, we get an equation in terms of lambda. That equation obtained, it is called characteristic equation. When you simplify, that equation will be in terms of lambda as a polynomial of degree n we get. If it is nth order, we get a polynomial of degree n. On simplification, we get it. Then, since it is a polynomial of degree n, if you find the roots of this equation, we get the roots that are called eigenvalues of the matrix, or it is also called latent root. So latent root or characteristic root or eigenvalues, all are on the same meaning, are nothing but these are the roots of this equation. So when it is asked you to find the eigenvalues of a matrix, what you have to do is just get this equation. If it is third order or second order, we can find the roots using your calculator. If it is higher order, then only you have to use some other method. But most of the cases, they give an equation of order. Usually they give 3 by 3 matrix. 3 by 3 means we get a polynomial of degree 3 only. That roots we can easily find using calculator. Get the roots. These are called eigenvalues. Now, next, what in by eigenvector? So you know how to get the eigenvalue of a matrix. For every eigenvalue lambda of this matrix, it is possible to find a column matrix, let it be capital X, such that when you multiply this matrix A by this column matrix, say A into X, answer will be again a column matrix. There we get lambda as the common factor. That means when you multiply this A by this column matrix X, answer will be lambda times X. That means when you take that, when you get a column matrix, there if we take the common factor outside, we get again the same column matrix itself. If it is satisfied, then this vector, that is column vector capital X, that is called eigenvalue of this matrix. So the simple definition of that eigenvalues and eigenvector. Now, from this relation, what you can observe is that eigenvalues you can find by using calculator, you can get it. But how to get eigenvector? For that, it must satisfy this condition. For every eigenvalue lambda, if it has n eigenvalue, for each eigenvalue, you can get a eigenvector using this condition. That is, now if you bring this on left hand side, what happens? Ax minus lambda x is equal to 0. 0 means it's a 0 matrix. The x is common. If you take it outside, a minus lambda into x is equal to 0. So what we get means the same equation again, but here in terms of determinant here. But for characteristic, for eigenvector, this is matrix A minus lambda into capital X is equal to 0 again. So solving this equation, we can find a value of capital X. Now let us see how to get it. We start with a small example. That means we shall take a matrix of 2 by 2 order. So first of all, you should know what is the eigenvalue and what are eigenvector. So before that, first we shall see some properties of eigenvalues and eigenvectors. When a matrix is given, why these eigenvalues are important? The reason is that when a matrix is given, if you know the eigenvalues without expanding or determining or just evaluating value of the determinant, you can directly find the eigenvalue. It has some properties. First one is that, suppose that a matrix is given, find all the eigenvalues. You add all the eigenvalues. The answer will be always the sum of the principal diagonal elements of the matrix. Suppose that matrix given, there is a principal diagonal elements like this. Add it. That sum must equal to the sum of the eigenvalues. So sum of the eigenvalues must equal to the sum of the diagonal elements of that matrix. Principal diagonal element from left side corner to right corner. If you go that, then that diagonal is called principal diagonal, right? So that sum is equal to sum of the eigenvalues. That's one property of eigenvalue. Another is, we find the product of the eigenvalues. That will be always equal to the value of the determinant. A matrix given, instead of expanding that one and getting the determinant, if you know the eigenvalue, find the product. That will be the answer for that. Immediately you can get the eigenvalues. That's another property. And for a given eigenvalue, don't think only one eigenvector. For a given eigenvalue, there are infinitely many eigenvectors are there. But for every eigenvector, there's only one eigenvalue. Reverse is not correct. For every eigenvalue, there are different eigenvectors. Infinite number of eigenvectors are there. For every eigenvector, there's a unique eigenvalue. So two, that is the next property. Two eigenvalues of a matrix cannot have a common eigenvector. That is, for a given eigenvector, there corresponds unique eigenvalue, right? And eigenvalues of a matrix and its transpose are always same, right? If you take the transpose of this, diagonal will be on the same. So that are some properties of this. Now let us see one simple example, how to get eigenvalues and eigenvector of a matrix. We shall start with the 2 by 2 matrix. Consider a matrix having 2 rows and 2 columns. So find all eigenvalues and eigenvector means first step you have to do is get the characteristic equation of this matrix. So first write the characteristic equation. What the characteristic equation means? This is the determinant of, don't think it is matrix operation. If you write like this, the determinant of, from this A minus lambda times I is equal to 0. Since I is the identity matrix, if you see the difference between these two, what we get only change in the diagonal elements, because in the identity matrix, all the elements 0 except the diagonal. So all the elements 0, because of that, when you get that characteristic equation for this matrix, change is only in the diagonal elements. Remaining elements remain the same. So how change is that? This 1 becomes 1 minus lambda. This 4 becomes 4 minus lambda. If another, that is the diagonal continue like this, third one is that element minus lambda. Like that you write remaining elements as itself. So we can directly write this one as characteristic equation is determinant of, write this determinant, and changes all elements remain the same except diagonal elements. What is the change in diagonal elements? That diagonal element minus lambda. So it is 1 minus lambda, 4 minus lambda is equal to 0. Like that, write the characteristic equation. But it is a determinant symbol. How to find the determinant of 2 by 2 matrix? Just multiply like this 1 minus lambda into 4 minus lambda minus 2 into 2. Like that you can expand. That is 1 minus lambda into 4 minus lambda minus 2 into 2, that is 4, is equal to 0. So right hand side must be equated to 0. Now expand it. 1 into 4, 4. 1 into minus lambda, minus lambda into 4, minus 4 lambda. Then minus lambda into minus lambda plus lambda square. And minus this 4 is equal to 0. This minus 4, this plus 4 get cancelled. Remaining is first write highest order term, that's lambda square. Then it is minus 4 lambda minus 5 lambda is equal to 0. It is a quadratic equation. If you are in the position to solve manually, means you can solve it. Otherwise, using calculator, find the values of lambda. These are the eigenvalues. In calculator, go for quadratic equation. For give the coefficient of lambda square and lambda and constant term, it will automatically give the answer. Otherwise, we can manually find from this lambda is common. If we take it outside, what we get lambda into lambda minus 5 is equal to 0. This product is 0 means either lambda is 0 or lambda minus 5 is equal to 0. So that lambda is equal to 0, one value get. Lambda minus 5 is equal to 0 means lambda is equal to 5 get. These are the eigenvalues of this matrix. So very simple method to get the eigenvalues. If it is 3 by 3 matrix, in that case also you have to go like that. There you get a cubic equation. When cubic equation is given, you feed all this coefficient to the calculator to give the answer that you can directly write. So that values are the eigenvalues. So eigenvalues are obtained. Next question is how to get eigenvector. But eigenvector you can find for each value of eigenvalue, right? For the first eigenvalue, one eigenvector. For another one, you can write another eigenvector. But eigenvector is not unique. At least one eigenvector you have to find. Now take the first case. When lambda is equal to 0, what is the eigenvector for this matrix? So I shall take the first case, that is lambda is equal to 0. But what is the condition for eigenvector? That is a column vector x such that when you multiply that a by x, you should get lambda into x. To bring left hand side, it is satisfy the same condition. That is, instead of determinant, this matrix 1 minus lambda, 2 into this 4 minus lambda into this x, capital X, that means eigenvector, that must equal to 0. So there is a condition for that. So let assume that x1 is, since there are two eigenvalues, first eigenvector I call it as x1. Capital X1 is nothing but that column matrix having two elements, x1, x2. Assume that this is the eigenvector. If it is the eigenvector, what is the condition? That is a minus lambda into this x1 must equal to 0. So there is a condition. So if it is the eigenvector, what we get this, then a into this is a minus lambda, this much into this. If you multiply this one, right hand side will be a 0 matrix. Under this condition, you can solve for x1 and x2. But what is lambda here? The case is when lambda is equal to 0. When lambda is 0, this becomes 1 minus 0, here 4 minus 0. So we get this matrix into this unknowns is equal to 0. Now multiply this 1 into x1 plus 2 into x2 is equal to, right hand side is 0 means there is a 0 matrix. All the elements are 0. So we have to equate each equation to 0. How we got this equation? Because since lambda is equal to 0, we get this one. So first equation is x1 plus 2x2 is equal to 0. For the second equation, 2x1 plus 4x2 is equal to 0. Now, here you got two equations with the two unknowns. But you have to consider only independent equations. Independent means, see, this is x1 plus 2x2 is equal to 0. What is the next one? You got this equation, multiply this one by 2. When you multiply this one by 2, how much you get? 2x1, 2 into 4x2 is equal to 0. So this is not independent equation. So only one independent equation there. That only you have to consider. Because this one is the multiple of this. So you solve only this equation. So since the second is multiple of this. Usually when 2 by 2 matrix given, only one independent equation you get, other one will be always dependent equation. So you take this equation only, that is x1 plus 2x2 is equal to 0, because this is dependent equation. Now if you take this on the right hand side, what you get, that is x1 is equal to minus 2x2. x1 is equal to minus 2x2. So x1 is equal to minus 2x2 means there's number of solution you can obtain depending on x1 and x2. So you write it as x1 is equal to minus 2x2 means bring minus to the left hand side and this one to the right hand side. This equation can be written like this. So the meaning is that if you equate this one to any constant, that much values are there. So x1, suppose that is ratio is equal to some k. So x1 is equal to minus 2 into k. x2 is equal to 1 into k. For different values of k, we get that much eigenvectors. But assuming k is equal to 1, we one answer we shall get. That is, one is x1 is equal to minus 2, x2 is equal to 1. That is one solution for that. So what is x1? That capital X1? Capital X1 means that column matrix having this unknowns. That is this minus 2 and 1. That means the answer is multiple of minus 2. x1 is multiple of minus 2. x2 also multiple of 1 minus 2 into k we get 1 into k. That will be the eigenvector when lambda is equal to 0. Similarly, we shall take another case when lambda is equal to 5. When lambda is equal to 5, suppose that another eigenvector x2, let it be y1, y2. So what is the meaning of this eigenvector? When you multiply that matrix A by x2, you should get right hand side 0. So that this is the condition for that. But lambda is equal to what? 5. If you substitute lambda is equal to 5, we get 1 minus 5 minus 4. It is 1, 4 minus 5, it is minus 1. This matrix you get. Simplify this. The reason lambda is equal to 5. When you multiply minus 4 into y1 plus 2y2 is equal to 0. Similarly, 2 into y1 minus y2 is equal to 0. Here also you may see that the first equation is the multiple of second equation. When you multiply second equation by 2 or minus 2, what happens? Minus 2y1 into minus means this element you obtain, minus of minus plus we get. So this is multiple of this, means I consider only the second equation. So second equation, this one, take this one to right hand side, then bring 2 this side, this 1 to the right hand side. This can be written as y1 by 1 is equal to y2 by 2. So what are the values of y1? It will be multiple of 1 into k we get. y2 will be multiple of 2. So this is the value of y1, y2. So you got the eigenvectors x1 and x2. So like that, we can get the eigenvalues and eigenvalues of a matrix using this definition. But in your syllabus, or more method is given how to get the eigenvalues using two methods. One is called Jacobi method, another is called that is Gibbons method. Using these methods, you have to see how to get the eigenvalues. But you have written for 2 by 2 matrix. Like that, you can continue for other matrices also. So resting, we shall continue in the tomorrow class. Right? Today we shall stop. Thank you all.
Thank you, sir.
Okay.
Thank you, sir.
Okay.